Good morning, all. Welcome to Nilit Calicut. Myself, Srijesh from VLSI department. So, I am the coordinator for this particular program which we are going to run here. So, you might have received a mail from our lab admin like this: lab access link and credentials. You can open that. So, see, in this video, we will see how we can try to access the remote hardware lab and how we can program an FPGA. Okay, that is what we are going to see. So in this we will open the mail from the lab admin, and you will find a link like this. You can click open that. Okay, you can click open that link. So you will get a page like this in which you have to enter your credentials. That will be also given in the mail. So you can give that. So you will now reach the remote hardware lab of Nilit Calicut. So this will be your desktop. You can do things in this particular window. So in this demo lab session, I am going to show you how you can program an FPGA. FPGA, how you can program, that is will be already covered in the theory session in the first video by me. Now we are going to see the demo of that. Okay, so now I'm trying to show you there is a cam shortcut in all of your desktop. You can open that. Now you can see the camera. This is the kit allocated to you. So the kit number is 481A and you are user number 1. Okay, so these batches are allocated accordingly, and you will be getting the batch wise schedule, and when you can access, then only you will get the mails for accessing this. During that time you can access the hardware lab and program it. So this is my so we should remember this particular number, and now we will see how we can access it. So you can right click and open a terminal here. Okay, you can open a terminal here. So I can open a Vivado. So Vivado is the tool which we are going to use to download and create the bitstream and download it onto FPGA. So this is the Vivado window. Okay, you can see the Vivado window. You can create a project. So creating a project. So I'm going to create a project for the VLSI beginners course, right? Okay, beginner course or something, any course. Okay, beginner. So I am going to put a counter. Now I am right now showing a 4-bit counter for you, because now you don't have access to the FPGA pins because it is sitting in Nilit Calicut and you are sitting in some part of the country or maybe outside the country. Okay, so I am going to show a program. This particular video is made such a way that you learn how to program an FPGA, not play with the FPGA. That will be learned in the advanced courses. Okay, that also there are options to remotely control the pins, remotely visualize the inputs. No need to look into the camera, but we can see the in outputs on our screen itself. All those things are available in the advanced courses which will come up. Okay, so now I am going to just see basic things. Okay, you can save your projects in the folder whichever you want on the desktop. Okay, go next. Now it's an RTL project. RTL, all of you know what it is. My colleague Mr. Nandakumar has already explained about Verilog HDLs and other things, so you know how to write an RTL now. Okay, now RTL, if I have a source, I will add that, or else I can create a counter. Okay, now I have some counter program here. Okay, counter 4-bit, not this one. Okay, I'll go back. We'll modify, or else if you want to create, you can create as well. Okay, so this is a constraint file. So we need, why we need constraint file, this is deeply explained in the first session, but we'll see why we need a constraint file. Is that we want to give the inputs and the outputs to the FPGA. So that is, and the timing constraint or clock constraint, we want to create a constraint file. So I am giving a pins, it is named as pins, or you can give any name, no issue. Okay, pins, and it is added to the project. Next. So now this is the most important thing, which is the kit you are going to use. So then you can see the camera, it is a RTA700T device. So now you want to do one thing, you want to open a Firefox application, internet Firefox. You can take internet also. You can log into our lms.calicut.my. Okay, so you can log in with your email ID and password which you have already supplied to you for the LMS. So now you can go to our browse our course, and here you will find the board details, FPGA board details. Here this is the Xilinx Vivado tool which you can download, web edition, okay, for practicing the simulation and other things. But you cannot download because it will be local to your machine and the kit is in Calicut, so you cannot download that. But you can obviously do simulations and create till bit stream, and you can put the bit stream via mail to the server and download. That's also possible. Okay. So this is the RT100T what you call user guide. We'll open that. So this is the user manual for the RT100T. Okay, so we should know what is the device name. So for that we are searching the device name. So this is our device name. X is 7A100T, T is TCSG 124A. So you can copy this. Okay, and we'll come back to our Vivado window. Okay, if this part is wrong, you will not get any of the correct things. Okay, so you can type, it is not copying pasting, allowing 7C. Okay, 7B. Okay, 1 minute. Okay, I'll just see what is this reference. 7A 100T. Okay, C 24. This is the thing. Okay, go next and finish. So now it is built. Okay, counter 4-bit. Open the counter. So it has some older things. I will remove that. So I'll open this file. Okay, so these are some other things which I have done. We'll remove those things. Okay, we need to add some portion of code to it. Okay, we'll just okay, we'll continue that thing. So now I have the program with me, so I'll just briefly explain this program. Okay, so you can see module, counter, clock, reset, and count is the port information. Clock and reset are the inputs, and output is a 4-bit count out. And I have declared some 26 bit temporary variable and a clock div. Why a clock div is required here? Because we have a system clock in this particular FPGA kit, which is 100 megahertz. Okay, 100 megahertz, which is connected to E3 pin. It is 100 megahertz. Okay, so 100 megahertz means the time period between two clock, that is time period T, is very high. It's in nanoseconds. So our eye doesn't have the capacity to identify. So blinkering of beats we will not see. So we are dividing the clock. So initially when reset is applied, we are giving the temporary value 0, clock div 0, that is initial reset, and then I am incrementing the temporary value by 1, and at a clock div is a clock which I am generating, taking the 20th bit of that temporary variable. So our main clock, E3 clock, will run. Okay, whenever the temporary variable 20th bit get toggles, so we will get a toggling in the clock div. So using that clock div I am trying to count. Okay, that's all. Nothing very serious about this. This code also will be available in the LMS. You can practice that. Okay, now you run simulation. Simulation is already explained earlier. You know how to run simulation and see the waveforms. Now I am going to synthesize. Okay, I will save that. Okay, so I have 36 cores in my machine. You can select. This is a very good server, so I am selecting all my 36 cores so it becomes fast. Okay, now I am running the synthesis. So whenever something is running, you can see here running synthesis will be displayed on this right hand corner, and here design runs also it will be shown, and we have some reports pane, logs pane, messages, TCS console, etc. Okay, so design run, it will take little bit of time. We should be patient enough. So we'll try to increase the font size in between that time. So settings, you will find settings, display. Okay, user defined, you can scale to 150. Okay, so now run implementation has come. So run implementation successful, synthesis is successful. You can give that. Okay, now if you want to see the reports of the synthesis, you can check on the reports. So here it will show all the reports in a bigger manner. So how many LUTs are used, okay, how many flip-flops are used. This flip-flop, because we have used a clock divider of 26 bits, so there are flip-flops used in this. Okay, like this, some summary you can see. Okay, any block RAMs used now, DSPs used. Yeah, bounded pins, because we have 4 outputs, 1 reset pin, 1 clock pin. So it is IO pins are used is 6, but we have a maximum of 210 in this particular kit. Clocking, yeah, clock buffers used is 1 because we are using clock buffer. Okay, now I will run implementation. Okay, so next step is implementation. Implementation will contain place and route, place, map and map. Okay, mapping, placing and routing. So those steps will be done. In that step we have something to be done. So we will go to our user guide. Okay, user guide, we need 1 clock pin. Okay, 1 clock pin. So if you are unfamiliar, you can even find it, and then you can give Control F and find clock. Control F will give you the clocks. So many clocks will be there. User clock is what we want. So this is the user clock. RTA7 includes a single 100 megahertz crystal connected to E3 pin. So if we map E3 pin to our clock pin, that means from the crystal oscillator an 100 megahertz clock will come to our design. Okay, so that is E3. So remember that pin. Now we want some switches. Okay, switch. Yeah, here you have basic IOs. So this is basic IOs, and I will tell you one more thing. So there are different kinds of banks for FPGA. Basically this is a FPGA. Okay, we should open implement design and then we'll go there. So let it open. We'll explain in this window itself. So there are different banks: 3.3 volt bank, 1.8 volt bank. Some FPGAs have some FPGAs have 2.5 bank, etc. So this FPGA is having 3.3 volt bank. So you can understand it via 3.3 here mentioned here. So now I have slide switches SW0, SW1, SW2, SW3 connected to A8, C11, C10 and A10. So I am connecting now A8 to my reset. So if I toggle this pin, reset will work. Okay, now I have H5, J5, T9 and T10 LEDs. So H5, J5, T9 and T10. Now we'll go to our implement design in the Vivado. Now you can see the IO ports are opened here. So you have all the output ports coming here. Now you can change these pins to this IO standard to input output standard to LVCMOS 3.3. Then you have to change it to the mentioned values. What are the mentioned values? H5, J5, okay, H5, okay, J5, P9, T10. Okay, now I have other two scalar ports. One is E3 port of the clock, that also you should change it to LVCMOS 3.3. okay, so if you are unable to see, I will just drag this up. Okay, reset pin, A8 pin, okay, again it should be changed to LVCMOS 3.3. this is what it will be written in the console. Now I will save, and now I should select the existing file for the XDC Xilinx design constraints. Okay, now we'll go to our sources window and we'll try to open our constraints folder. Now you can see set property IO standard LVCMOS get ports count of 3, like that, some standard. If you are an expert user, you can directly write this. There is no need of this GUI editing. If you are an expert user, you can type in this constraint file and save it. Okay, you can save it, and then you can give generate bit stream. So it will generate the bit stream. So it will, if the changes what we have made is affecting the earlier stages like synthesis implementation, if you run a lower step, it will rerun all the top from the top automatically. Okay, so now there are other LEDs, tricolor LEDs also. If you give a 1 to this G6, it will make the red, the tricolor LED glow red. If you make this F6 1, then it will give green. If you give E1 1, then it will the blue will glow blue with blue. So similarly G3, J4, G4. So you have 1, 2, 3, 4 tricolor LEDs which you can glow accordingly. So I am going to give you an exercise in this particular course, so that you can make a 4-bit counter, and I am now trying to glow it on a green LEDs. You should make it red. Okay, you should make it red. Okay, one. Another program you can make it green, and another program you can make it blue. Okay, in 3 programs you should try in this given time. It is very easy. Only constraint file you need to change. So it is writing the bit stream. After that we will download. We need to okay, now you can open the hardware manager. Okay, the hardware manager will be opened like this, and you can now connect. Before that we will take our kit here. Okay, and now I am going to connect. So it will connect to all the kits. There will be, you will be seeing some 9 kits here. Okay, you will be seeing some 9 kits. So which one I should program? That is a question. So I should open my cam player. I will find it is 481A. So I will find 481A in the last. This is the last 4 digit displayed here. You can right click here. If you are unable to see this, you can maximize this, no issue. 9 kits, it will be totally 12 kits connected to it. Now only 9 is connected. You can select 481A, open the thing. Okay, now you can right click, you make the cam here. You can program the device with the counter bit. It will automatically point to the counter bit. Okay, okay, now I will program it. So you see it is now it has gone num, and then it has started. Now I will program it. With some other thing, and I will show you. If I try to program with this, it will tell wrong because it is not that program's bit file. So I will take this same bit file. 1 minute. So what you are seeing in the cam window. Okay, now it's done. Okay, I will take one more. So where it was, desktop, FPGA projects. So where will be the bit file? It will be in the runs folder, implementation. You will find this. Okay, now you will just lively do it. I'm programming it. So now it is gone, and now it will start blinking. If you want to change the inputs, right now we are not giving an access to you. In the advanced courses coming up, we have FPGA programming, architecture and programming course. We have many courses coming up in which we will make you learn all these things. Okay, so this is how you can program an FPGA kit using our remote hardware lab. So if you have any queries, you can always ask in the WhatsApp group or in the doubt clearance sessions coming up. Okay, thank you.